and I'm so jealous of you to have access to FSD in Tesla. But have you tried it out then to just make it go from point A to B in some way?
Yeah, I use it to go to work.
Yeah.
Go from work, it's about 30 to 40 minutes drive from my home to our office in San Francisco.
And it works well without any interventions, or how well does it work?
It works pretty well. Like I maybe have to intervene maybe once or twice in the whole drive, but also not for something risky. It's more like just I don't like how it picks the lane or something like that. And I tried FSD on a friend's car. I think it was maybe 2 years ago, and it was pretty bad then. Like it was actually dangerous. In a short drive, there were multiple interventions we had to do. Yeah. But now I think it got much, much better.
Is it version 12 or which one do you have, you think?
Actually, I don't know. I did need to do some kind of a software update to get it, but yeah, I have no idea what version it is.
Yeah, and for people listening, Tesla, and please correct me, you just told us this, but Tesla just opened up FSD for free for everyone for a month in US, basically, right?
In North America, yeah.
Yeah, that's super fun and exciting to really being able to try out. And your experience so far is positive, right?
Oh yeah, I think it's incredible, and all of us working in the AI field, I think it's kind of sometimes hard to see the progress, right? The big picture progress being made. But autonomous vehicle is one of the original key applications for AI. And it took quite a few years actually to get to where we are now. But FSD in Tesla is, in my experience, actually working super well. In San Francisco, where I live, you can already take driverless robotaxi with Waymo, which is also an amazing experience. It feels like you're in a Harry Potter movie where the car just moves by itself. The wheel is moving, takes you from point A to point B.
Have you tried it out, the Waymo taxi?
Yeah. I used Waymo a few times in San Francisco, and it's pretty incredible.
Which one would you put first? Which one has the best full self-driving, you would say, today?
Probably Waymo. I think, I think it's one thing where there is a driver behind the wheel and, the driver can intervene at any given point of time. And, they do require you to put the hand on the wheel. In the Waymo, it's like fully autonomous. You just order a car, it comes by, it stops close to where you are. Doors, unlock, you get in, the car goes. No one is in the driver's seat. It just takes it to where you need to get. And it's very smooth, very careful, but also kind of, getting to where it needs to get.
I think next time we need to record a podcast from a Waymo in the US.
Yes, that would be fun. And so exciting to hear about this, and I'm very jealous, as I said, for you to have access to FSD in your car right now. So great to hear.
Do you have any fears that some people will need to intervene and not manage to intervene, like this thing? Based on your experiences, are there any risk, do you think, of a pushback from people?
I think safety-wise, I think definitely, I would actually wait for the regulators to kind of call it out as, the same kind of quality bar that Waymo has hit. And regulators in the US do kind of review Waymo's technology, required Waymo to do a bunch of experiments and prove that it's safe. I don't think Tesla has done something similar just yet. So I would definitely, when I'm using FSD, I'm definitely in the driver's seat. My hands are on the wheel and I'm paying attention. So I definitely don't think it hit that safety bar just yet. But I think it's just a matter of time. With enough training data, enough mileage, this technology if it's not already, it is going to be much safer than humans. Because, the machine doesn't drink, doesn't have to sleep, right? All it needs is electricity and software updates. And so it's much safer than the average human.
Yeah, true for that. Perhaps for software engineers as well soon. But before that, I'd love to welcome you here. It's an honor to have you, Hagay Lupesko here. or here. You're rather over there, I guess, in California, joining us online here. But you're the VP of engineering at MosaicML, right? And you're now part of Databricks these days. Since, was it last summer that they acquired MosaicML?
Yeah. It was last July. MosaicML. We were a San Francisco-based startup acquired by Databricks, and now all of us, we are part of Databricks. We are now called within Databricks the Mosaic AI organization, and we basically work on all of Databricks AI platform capabilities, from Gen AI up to what's called today traditional ML.
Awesome. And one of the main reasons, of course, that you're here is the announcement of the new Databricks large language model called DBRX. And you've been a key member of that team, right?
Yeah, I mean, there's a lot of incredible people have worked on DBRX from, shortly after the acquisition. And I'm part of the team that, built the model, made it available on the platform, along lots of super talented people from our research team, our engineering team, and then even, product, marketing, legal. That was, pretty big effort across the company.
Awesome. I'm looking very much forward to this discussion and hearing more about, how it was actually built, why you chose to make it open source, which is amazing and great. But also perhaps getting some secrets for how you actually made this model perform as well as it does. Outperforming Grok, even though it's like, I guess, 3 times bigger or something like that, and still made it work as well as it does.
Super good at coding also. That's really nice to see.
Yeah. But before we go into those details, we'd love to just hear very briefly about your background. Who is really Hagay Lupesko? Before you joined MosaicML and Databricks, how would you describe yourself?
That's a good question. How do one describe themselves? Well, I guess, professionally, I think I was fortunate to work at quite a few really great companies. I started my career as a software engineer, 20 years ago, whatnot. Worked at small companies, larger companies, focused a lot on computer vision early in my career. It wasn't called AI back then. Most applications didn't use neural networks. They were not considered to work well, were very hard to train. So the way computer vision was done back then was very, very different than how it's done today.
You were working in medical imaging, right?
Yeah, I was medical imaging, working at an Israeli startup at the time. Later moved to GE Healthcare, working on cardiology applications and radiology applications. So that's like very heavily image-based systems. And then about 10 years ago, I was relocated to the US by Amazon. So Amazon, they were looking for people all over the world and bringing them to the US. So they brought me to the US, to California. That's where I've been in the last 10 years. And, for me, it was professionally, it was really important to get to Silicon Valley here, which to me was like, the center of software technology, right? Globally. And really a small area with condensed, a lot of technology companies, startups, VCs, right? All of that soup was super interesting to be a part of.
I can see that, but I think Israel as well is a very, tech startup dense area, right?
Yeah, 100%. Israel, I think maybe, second or third in terms of or maybe even first per capita, I would guess. But still the scale, right? The scale in Israel is nowhere near the scale in Silicon Valley. I think Silicon Valley probably, there's no other area that comes close in terms of the tech ecosystem, I'd say. So anyway, so I worked for about 5 years in Amazon, starting in Amazon Music and then moving to AWS. And at AWS, I actually helped build SageMaker. Those were the early days of the industry adopting neural networks. And SageMaker was a key product that Amazon launched back then to really democratize machine learning and deep learning.
We were actually competitors at that time, because then I worked at Peltarion and we saw SageMaker as a competitor to us, actually. But we're friends anyway, so it's good.
Yeah, no, those are very dynamic times, I think, and lots of companies were kind of rushing to, figure out what's this thing called neural networks, how it can be used, and we just spoke earlier about self-driving cars, and I think one of the early applications of neural networks was back then autonomous vehicle. I mean, back then there was a lot of that field was very hyped. There were a lot of investments going into the field and lots of training jobs for what we back then thought were really large models that were, the ResNets of the world. And of course, in comparison to large language models today, those are tiny, tiny models. But anyway, that was exciting. So we shipped SageMaker and, deep learning engines and inference services. And SageMaker, by the way, is still, I guess, or was until recently, AWS's fastest growing service across all of their portfolio of services. So definitely it was very successful.
Yeah. And then you moved to MosaicML at some point, right? How many years ago was that?
So after AWS, I moved to Meta, and I was with Meta AI for about 3 years. And again, Meta is one of those companies in terms of AI, they like work in the future, right? Yes. They're doing things that other companies or most other companies would be doing, in a few years from now. So that was exciting. And again, Meta was moving back then a lot of their recommendation systems, which is the #1 ML application in a company like Meta, and I'm pretty sure the company like Google as well. All of the recommendation systems, they were moving from being tree-based models into being deep learning based.
Right.
And and I worked a lot on that effort. And by the time I left, there were about 3,000 models within the company, recommendation models that were using neural networks for, serving recommendations. So from, feed recommendation to ads ranking to, marketplace listing ranking and all of those models. And it was very successful. Like neural networks were definitely beating, all the other more traditional ML models for recommendations. And a lot of it was just because, a company like Meta has a lot of really troves and troves of data that they collect. And what's nice about neural networks is they scale, they become better the more data you feed them. With more traditional ML, what we found is that kind of the ability of the model to improve at some point kind of is diminished. But with neural networks, if you increase the model capacity by adding more layers or making layers, larger, then the model is capable of learning more from the data.
It just keeps scaling, right? The more data, the more parameters you have, it just gets better and better in some way.
Yeah, exactly. And so and then after that, I moved to MosaicML. I kind of decided, hey, maybe it's about time after, big companies like Amazon and like Meta, maybe go to, downsize a little bit, go to a smaller company.
How big was the company then when you started?
When I started with Mosaic, I think we were about 30 people. So fairly small, if you compare to, Amazon's, I don't know how many employees they have, 1 million or whatnot. And even Meta, when I joined Meta, there were, I think, about 30,000 employees. When I left, it was close to 100,000. So yeah, much smaller. And I came in to lead the engineering team, which back then was also fairly small. Like I think it was maybe 10 people, 10 engineers. So yeah, it was exciting. Small company. Kind of tightly knit, everyone working very closely together, very clear mission, very clear focus. So it's a very different environment than you have in a typical large company. And that was, for me, it was a lot of fun and very exciting and really a refreshing change.
Awesome. And I'm trying to rush ahead a bit because we want to move into DBRX as soon as possible. But perhaps you can just quickly describe, what happened when Databricks acquired MosaicML.
Yeah, so I think Mosaic, just kind of very briefly, Mosaic, we built a platform that focused on training large models, in general, large deep learning models, and doing it efficiently and allowing researchers and ML engineers to really experiment quickly. And we were building this platform, kind of this big wave of LLM came in, and suddenly everyone wanted to train a large language model, or at least the medium to large companies. And I think we had the right platform at the right time. We kind of focused our platform and all of our efforts into really perfecting our platform for building LLMs. And as we were doing that, we also decided to train our own models as sort of a proof that the platform works really well. So we built an open source two models, MPT-7B and MPT-30B. So that's 7 billion parameter model and 30 billion parameter models. Those are dense GPT style models, trained on 1 trillion tokens each. And those models were very successful. We open sourced them, and it really allowed the company to kind of turn a corner, because we got a lot of visibility when we open sourced these models, and a lot of customers came in, and our revenue started increasing, and we started onboarding a lot of customers. At that point, we also added inference to the platform. So once you train a model, you can also deploy it for inference. And we were on a kind of a really good path, very painful path, because you have to, grow and serve more customers, but also, successful.
You said
and at
inference
that point,
to the,
I think,
so you said inference to the platform. Do you mean the Databricks platform then, or did you mean MosaicML platform?
No, we built the MosaicML platform. It was before the acquisition.
Right.
But then, as part of that also, we kind of, I guess, got on the radar of Databricks, and Databricks were already, having a pretty successful platform, right, based on Spark, and they're expanding it to, data warehousing, but also more generative AI capabilities. And I think they just saw us as being very complementary to what they were building. And, what's amazing to me is from the first conversation, or at least to the best of my knowledge, first conversation that, the two CEOs had, Databricks CEO and Mosaic CEO, to the time the acquisition actually closed, it was literally 2 months. So 2 months from the first conversation until we were actually Databricks employees. And it was a fairly large deal. It's about $1.3 billion of an acquisition. And I'm still amazed how such a big acquisition could kind of fully close within just, 2 months.
That's
which
very
is,
quick.
it's incredible. Yeah.
Yeah, amazing.
And nice to get going as
yeah.
early as possible in the new sort of role.
Yeah, so I think, as we all know, right, the AI field moves super fast. Nobody is waiting for any, too lengthy of due diligence or, negotiations and things. And I think the two companies just decided that it was a good fit on both ends, and just to move on with it. And within 2 months, we were Databricks employees. And
so I'm trying to move into DBRX now. So was that initiated during the Databricks time, and what was the sort of goals of this model? Was it just an improvement on the earlier models, or is this part of the Databricks sort of offering now?
Yeah, it's a great question. So, like I mentioned earlier, like in Mosaic, we were already deciding that actually us training models on our platform and then open sourcing them is a good thing. And it's a good thing because of a couple of reasons. And that strategy kind of carried through also into Databricks. First of all, all of us in the AI community, we're kind of building on top of one another. And I think that's one of the key things that allows us to move so quickly, because most of the research is done in public. Even today, most research papers you see out there come with some kind of code attached in GitHub, especially if you're, showing some results. And it allows everyone to use what the others did, build on top of it, and all of that, of course, while recognizing that we're all sort of standing on the shoulders of giants, if you will. So for us, one thing was, hey, we're actually leveraging so many things built by the community. We want to make sure we contribute back.
Yeah.
And we contribute back, to help the community, but we also realize it helps us as well.
We have another topic going into depth about the open source versus closed source. So we'd love to hear more about your thoughts about, the pros and cons of doing that. But perhaps you can just speak a bit about the origins of DBRX. Was that initiated after the acquisition, and what was the thinking there, moving from MPT, I guess, into DBRX?
Yeah, so DBRX was definitely initiated after the acquisition, but the core people or the team, really the Mosaic team that was building MPT, mostly continued to build DBRX. So the motivation was very similar to why we built an open source MPT, and everything kind of carried through. So I guess the main thing that changed is, or the things that changed were, first of all, the naming. So we went from MPT stood for Mosaic Pre-trained Transformer, and we changed the naming to DBRX to kind of be associated with Databricks very clearly. And then of course the model where we if you think about it, the model DBRX is a much more powerful model than even the larger MPT 30B, and we recognize that the industry moves quickly, models becoming larger, more sophisticated, and we wanted to make sure we have a really good open source model out there. Where we ended up is with the best open source model today. If you look at most evaluation metrics, and that's where we were targeting. But we weren't sure that we're actually going to get there, right? Because it's a very, very tall order, very tough task.
How did you? I think we can move more into some practical details about the model and the architecture. But how did you come up with exactly the architecture with a mixture of expert approach, with the 132 billion parameters, etc.? How did you decide to do that? Did you have some ablation studies? Did you have some reasoning about different approaches? How did you come up with a final architecture?
Yeah, so we have a fantastic research team at Mosaic, and the research team definitely did a lot of studies. And the training itself took about 2 months net, from when we started the full training until it ended. But there were quite a few months before that where there were a lot of evaluations being done, a lot of experiments to look into things like, first of all, one big decision was mixture of experts versus a dense model. When we started doing our work, it was definitely not clear that MOEs, are going to give us what we're looking for in terms of, training a model that is more complex with higher capacity of learning and, higher quality target, but at the same time being efficient to serve. And we come from a very practical standpoint. I mean, our customers, both at Mosaic and now at Databricks, they are enterprise companies. And enterprise companies that want to leverage AI, but they also recognize the price tag that generative AI has. And to be clear, serving a large model is very expensive. And the larger the model is in terms of number of parameters, you need more expensive GPUs to serve it, and your throughput is limited, etc. So we were trying to find the right balance between quality of the model and serving cost. And MOE seemed to be like a really interesting approach, but we had to do quite a few experiments to compare MOE with dense, make sure we are actually getting the benefits for both training and serving. And when we started that, it was actually, Mixtral was not around back then. Grok 1, which is also an MOE, was not out. There were rumors that GPT-4 is an MOE, but it's really hard to know what's going on at OpenAI because it's pretty closed these days. So we definitely did a lot of experiments. MOE versus dense was one of the key experiments. And then, there are a lot of, hyperparameter choices for the model architecture. And we ran dozens and dozens of different experiments on our Mosaic platform that helped us really choose the right architecture. So that was sort of step one.
And
once
before we move on, after mixture experts, I mean, you have chosen a bit of a different architecture or hyperparameters for the mixture of experts than Mistral and Grok, etc. It seems you went for 16 experts instead of normally 8, I guess, and you also have 4 active experts at every time. Yeah. How did you come to that decision? What kind of insight made you choose that, and why do you think others chose some other approach?
And also to add on to that, do you think the continuation will have even more experts, or is this sort of a sweet spot?
So what made us choose this specific setup? And like you said, we have a number of experts, 16, and then active, the top page 4. And yes, Mixtral as an example has 8 and 2. So first of all, we theoretically, there's a trade-off here, right? The more experts you have, the more top K, right? It impacts the total number of parameters the model has, as well as the total number of active parameters during inference. So there's a trade-off here. The more you increase these values, you get more complexity in the model, which theoretically means the model has better capacity of learning. But on the other hand, training becomes more expensive and inference becomes more expensive. One way to think about that mathematically is if you look at the combinations of 16/4 versus the combination of 8/2. With what we have, there are 60 times more combinations for each router. So theoretically, one way to think of it is, yes, it kind of increases the model's capacity and the ability of the model to perform better in terms of quality.
And just to elaborate,
but then the trade-off is serving. Serving becomes more expensive, and training becomes more expensive as well.
Just to elaborate, to make sure that people understand a bit there, that if you have an 8 and 2 active, you have only like 8 one to choose 2 from, so to speak. 2/8, and when you have 16, there is a lot more combinations to find the 4 that is actually the best for each token. So in that way, it's 60 times more choices to make in some way, right?
Exactly. Yeah. Specifically, the number of combinations when you choose 2 from 8 is 28, and the number of combinations of choosing 4 out of 16 is 1,820. So we get basically 65 times more combinations with our approach. Now, I would say this is in theory. We did a lot of experiments with different setups, different parameters to validate this theory, and we got results that kind of made us pick 16 experts with 4 active at every router.
Yeah, I'm super interesting. Do you think the future will go in this direction to just have more experts, or, as you said, Jesper, do you think there will be a sweet spot where you find the suitable number of experts depending on parameter size or something, or what's your thinking there?
Yeah, I think, first of all, MOE, in my mind, is here to stay, just because I think it's very impractical to continue increasing dense models, just because serving becomes too expensive for most practical purposes. So MOE is here to stay. Now, in terms of the specific, hyperparameters chosen, I think we don't know enough at this point. I do expect a lot of research to go out, in academia and from the industry about the approaches, and we may see something even more complex, or maybe we are actually differentiating this setup of number of experts and top K based on the layer the router is in. Today in DBRX, in Mixtral, it's the same number of experts and same number of experts chosen at each layer or each block. But going forward, this may change as well. So I think it's still early days for Mixture of Experts. We'll learn more as we go.
Awesome. And the context window, it was 32K, right?
Yeah.
Did you, there are some, like Rock, I think, at least in 1.5 has a bit bigger, but 32K, I guess is rather big for open source models. Did you have any thinking there in, the size of the context window?
Yeah, so we trained the model on 32K context length. When you use the model, you can actually use larger context length. We just, it will probably not work as well because it was not trained on larger context windows. And then, of course, the other practical limit you have is just memory on the GPU when you're doing serving, because the longer the context window, the more you need memory for the KV cache and for the computation. We chose 32K because we thought this is what enterprises need. When we look at practical applications, so again, being part of Databricks, we have more than 10,000, I think now it's like 12,000 customers or whatnot that are on the Databricks platform. Many of them are trying to build AI applications. And, we try to really be attentive to what they're trying to do, what are their needs. And so we chose 32K because we believe it's a really good, it addresses their needs. And then, of course, it helps us keep the serving of the model more practical and, cost efficient.
So it's basically
when you think of,
So it's like a balanced choice to make it for one practical and economically viable, but also still useful for enterprise use cases in some sense.
Exactly. Yeah. And the main reason, by the way, people need this large context window, and I'm talking about more practical applications for when they implement RAG. And in RAG, typically, you do retrieval, you pull into the prompt context that is going to help the model give the right answer to the question it's being asked or to the completion it has to do. And then, with all these retrievals, the context may actually grow quite a bit. But 32,000 tokens is almost kind of an average novel if you think about it. So, there's plenty of room to put in a lot of context into RAG applications with 32K.
Yeah, I can't help thinking about. I think it was maybe Bill Gates who talked about the RAM in computers. It feels a little bit like that. Was it like 64K or whatever is more than anybody will need?
640K.
640K. It feels so far away anyway.
Yeah, we'll see what the future will.
Yeah. Well, I'd be super happy to be in the same camp as Bill Gates.
Just a final question about the training aspects of DBRX. You used like 3,000 plus H100s, right? Or what was the hardware setup for training DBRX?
Yeah, we ran on a Mosaic AI cluster with a bit over 3,000 H100s. And that was the hardware. Very importantly, interconnected with InfiniBand, which is super critical for large-scale distributed training. And it was all orchestrated by the Mosaic AI platform, which dozens of companies already use to train their own large models. That platform is doing, orchestration, deployments of the container images, configuration of the GPUs. And then most importantly, and something I think people kind of often overlook is fault tolerance of GPUs. Because when you run, our training job for DBRX ran for about 2 months, or give or take, on this large cluster. And when you run a job for that long on so many GPUs, many of them are going to fail. And, it's not an if a GPU is going to fail, GPUs are going to fail. And it's really important that the system you have is fault tolerant, meaning, it's capable of detecting these failures, pausing training, replacing the failed nodes with fresh nodes, and then resuming from the last checkpoint, and being deterministic about the resumption is really important. So, if some of the nodes already saw some of the samples, you don't want them to see the same samples again. All of that has been, is orchestrated by the Mosaic AI platform. And that was a key part of actually being able to train DBRX.
And I guess a lot of people underestimate the infrastructure needs or the code necessary for just having these kind of large scale training sessions to happen. And if you don't have a proper AI platform underneath that can help you with this, it will be a lot of headache. Is that correct?
That's 100% correct. I would even take it to the extreme, and I would say you cannot train a model like DBRX without a really good software platform. And I think in some ways it's like, when there's this analogy of an iceberg, right? When you see an iceberg over water, it's really impressive. It's this, big thing that is hovering over water, but actually the most of the mass of an iceberg is underwater. And in my mind, it's like, the software infrastructure needed for the model is kind of that part of the iceberg that is underwater. It tends to be a very Herculean software engineering effort that enables the AI researchers to actually do their work, both quickly, but also just being able to really just achieve that goalpost of training a large model.
And speaking about the Mosaic AI platform, is that going to be, given that you're now acquired by Databricks, is that going to be offered somehow through the Databricks platform as well, or how is that going to be integrated?
Yeah, no, it's already offered. So Databricks, what used to be the Mosaic AI training platform, is now called MCT, Multi-Cloud Training. So that's the same platform. It was used to train MPT models. It's used to train DBRX models. And then there's also dozens of customers that also trained LLMs on this platform on their own data. So it's already there, available. And, you know, if anyone in the audience is interested in training their own LLMs, they should, you know, reach out to me and we can get you connected with the right people at Databricks. Yeah, so it's already there.
And I guess some customers or potential users or listeners are thinking, okay, 132 gigabyte model is a bit big. Are you going to release some kind of smaller models as well that people can more, you know, cheaply and quicker adapt to their needs?
We're definitely thinking about it. And if you actually look at our technical blog announcing DBRX, we are mentioning a couple of smaller models that we trained before DBRX. And we were thinking potentially making those available as well. And then eventually we decided to just focus on really, we're not such a large team. So we wanted to focus on really offering the base DBRX and doing a really good job with that. But we are thinking about smaller models that will be more practical to some customers. And I agree. I think some companies definitely would be interested in serving a model like DBRX, where it hits a good trade-off between, you know, quality and serving efficiency or serving costs. But then there are a large segment of customers that would want a smaller model. And I've seen a lot of examples in our customers of customers who took a smaller model, like a 7 billion parameter, you know, Mistral or MPT-7B, fine-tuned it for their task, and got good results that were comparable to something like GPT-4, you know, for that specific task, of course, not general purpose, but just for a specific task. And then the serving cost of a 7 billion parameter model is, you know, smaller than, you know, calling GPT-4 by probably 2 or 3 orders of magnitude. So it's a very practical approach for enterprises. They already are doing it. So yeah, we definitely are thinking about making a smaller model available. But, you know, just the call out I'll make is there are already great smaller open source models out there.
Right.
You know, again, Mistral 7B, Llama 2 7B. And, you know, you can already take these models and you can fine tune them on the Mosaic platform, or you can even pre-train these models from scratch on the platform. You know, the architecture is open source and you can just do it.
Yeah, awesome. Let's move into the other topic. We started speaking about the open source versus closed source. And you have chosen, of course, to my happiness, to go with the open source direction. Can you just elaborate a bit more about the thinking behind that? I know you did it also for the MPT models, but what do you see as the potential pros and cons with going open source?
Well, the pros are, I think, you know, easier, right, to highlight. I mean, contributing to the community, right, helping the community build on top of what you build, but also putting your code, your model open source allows the community to tinker with it, to improve it, to find issues with it, and then it all, you know, is contributed back. So it's almost like, you know, you get a lot of improvements to the model or to your software relatively, you know, easily and relatively cheaply. So I think that's a sort of a win-win on that front.
Sorry, can I interrupt? How fast would you see those contributions coming in? Did you already see something? I was thinking about, I saw something from Gemma, I think, from Google. It had lots of issues, and I saw people were posting those problems at an early point.
Yeah, you know, I can tell you, I spent the night when we open source DBRX, I spent the night at the Databricks office with a lot of my colleagues, you know, to kind of make sure the release goes well and, you know, flip the flag in our platform to, you know, to make the model and the serving available and all of that. And I can tell you, like within the hour from when we announced it, comments, suggestions, and even PRs started flowing into our GitHub repo.
That's
so
nice
the community
feeling.
is amazing. Yeah.
What about the cons
and
then?
I think.
Yeah, sorry. Please.
Yeah, I'll just say I think one thing to highlight. someone already made DBRX 4-bit quantized available on open source, so people can actually run 4-bit quantized DBRX on their MacBooks.
Oh, I saw that.
I thought was incredible. Yeah, they didn't even talk to us; they just did it. Amazing. So
open source is amazing when it works. But just thinking about potential cons and thinking about the potential like safety aspects of it, and if you were to release something and it doesn't have the safeguards in place, and people are starting to abusing it, I mean, it will be really hard to retract it, right?
Yeah, I think that is the challenge in I think every software you put out there. It basically you lose control over it, right? And by the way, it doesn't matter what license you have in place, because some actors, right, would abide by the license, and some actors would not, unfortunately. So it's out there, and people will do whatever they want with it. And I think to your point, this point is more significant for AI models because these models, they have kind of very strong capabilities, or they may have very strong capabilities, so they can be used for different things. And I think over here, like there are, let's say, two major camps, right, in the tech world. One camp says, hey, we should keep these things closed so we can control them and we can ensure safety. And the other camp is saying, no, actually, the best thing is to put things out there so that, the community actually helps us find the issues so we can improve faster and really have, better coverage to find issues and problems. So those are like the two camps. And I think, I don't know if you guys remember, there was recently like a call to pause development, and some companies have been arguing that, hey, we should actually put very strong protections in place. So, LLM technology or generative AI technology is, monitored more closely and not as publicly available. I think it's definitely is a tough call. My personal view of this is, I think companies need to make best effort to make sure their models are safe, right, before they release them. And this includes, doing things like red teaming before launching a model and taking the time to do safety checks and evaluation and all of those things, which are things we did, by the way, before we released DBRX.
Right.
And I think, other companies are doing as well. Like I was actually super impressed by Meta's work with Llama 2 on safety. Like half of their technical paper about Llama 2 is about safety. And I think that's, that's really, really impressive and important work. But I also think that, one company, the amount of really full testing they can do and safety checks and safety work is still limited. And it's not anywhere near what you can get by putting it in front of the whole community.
Yeah.
And I think putting it out there would yield better results. And like one reference I can, my intuition comes from kind of working in software for a while. And I look at the most secure server operating system, and it's not the closed, Windows.
Right.
It's actually the open Linux. And
so I guess I think you could argue, as you say, that safety aspects is actually potentially better off by open sourcing it because more people can look into the issues. Yeah,
exactly.
Awesome. And I'm sorry for rushing a bit here, but time is flying away so quickly when we have fun. But if we were to move to, I think, one of the most interesting topics, which is, let's call it the secrets of DBRX. I mean, it is a bit surprising how well it actually does work. It works really well for coding, apparently, to what I've seen, and math problems. And also it outperforms like Grok 1 that has like 340 billion parameters, and this one has like 132. Can you just try to elaborate a bit more? Why do you think the performance is as good as it is?
Yeah, I think it's a great question. I don't think there is one answer to it. I think there's multiple factors, and I can try to maybe go through some of these things. And we have kind of touched on some of them already. I mean, the first thing I think is the model capacity. Again, it's a mixture of experts model, total of 132 billion parameters with 36 billion active on every input. And we found this setup to work really well. Like again, like it's a good trade-off between quality and efficiency. Now, it's true that Grok 1 actually, I think, is maybe twice as large or whatnot, but Grok 1, from what I understand, the version that was open source was trained on a much smaller number of tokens. And it's important for everyone to remember, the scaling laws, right? There was a paper from Google a while back. I think you refer to it as the chinchilla paper, but it really explored that trade-off, like getting to higher quality, scaling the model capacity, the model size, and then also the data. And what that paper found is actually you need to scale both if you want to really be optimal in terms of the model capacity. So we train DBRX on a pretty large amount of pre-training data, about 12 trillion tokens. That's 6 times more than Llama 2 70B, what Llama 2 70B was trained on. I believe it's much more than what Grok 1 was trained on. And I think that's a key factor in why the model is performing so well in terms of the quality. Now, I would say it's not just the amount of the pre-training data, it's also the quality of the pre-training data. And we took a lot of effort to curate our training data set. It's all based on open data sets, but it's curated, meaning we evaluate literally each and every token to make sure that we feed the model with high quality training data. And we also implemented some form of curriculum learning. So there's a bit of that as well. And I think that was key in achieving quality that we achieved.
Sorry, could you say something more about how do you make sure that the data is good? It seems like such a key question to have the right data. How can you make sure that you only put in the good data?
Yeah, I don't think we have enough time to dive into it. Maybe it can be another session, but the internet contains a lot of things, a lot of high quality content and a lot of things that are, I'd say low quality, right? Like bad carbs. And we build a lot of mechanisms and algorithms to allow us to differentiate the two and, to run those systems on the open data sets to differentiate them. Exactly how we did it, that's requires a deeper dive.
Let's move on.
Yeah, and just a very quick note about the curriculum learning. Can you just elaborate a bit more? Do you go to some, for first easier tasks and then move to more difficult ones, or how did you go about doing that?
Yeah, we again, there's a lot of details, but one way to think about it is, again, kind of differentiating the training data from not lower quality, but simpler data set that teaches more of the basic concepts of language, and then having other data sets that contain more nuanced notions, more complex notions, and then just making sure the order of training and the mix of the different data set is such where we are gradually increasing the complexity of the training data. And that in our experiments, it actually works pretty well.
Yeah, awesome. That sounds very logical and reasonable. And let's move quickly into the future of LLMs. And I would love to hear if you can, disclose any kind of future of DBRX and what the next version would be. And we have some directions to go in. It could go into these kind of infinite context window sizes, so 1 million plus tokens, or not. We also have what Jan LeCun and Meta is speaking about a lot, which is the JEPA kind of architecture where you do the inference in the middle, in the latent space instead of the token space. I guess we have the Q-star thing as well that OpenAI is looking into. Do you have any thoughts about the next steps for DBRX and where the potential changes will happen coming year?
Yeah, I think the field, again, is moving so quickly, and it's kind of hard to try to predict the future. I can tell you what is our focus. Our focus is really on kind of enterprise applications. We want to make the Databricks customers successful, and what they're trying to do is really implement generative AI applications. So short term, at least, we'll be looking to see how we can adapt, improve, take the next step with DBRX to power as many enterprise applications as we can. And some part of it may be, we actually, I can't share any concrete plan at this point. Part of it is because we're still thinking about it ourselves, but one part can be actually offering, variants of DBRX that are more practical for enterprises. Part of it may be actually improving DBRX, and you can think about a lot of, potential fine-tuning we can do with DBRX as an example to make it better at specific areas or domains. And part of it can be just, hey, let's increase the quality of what we have even further. And there are definitely paths for us to do so. We want to, in general, continue contributing to the AI community by making more things available, on the open source, but also continue to have really good offering for enterprises who are, using Databricks today and want to be able to adopt generative AI. Industry-wise, I think, I think we're going to still see bigger and better models, but I don't think we hit that ceiling just yet. I think there's still, training larger models on more tokens still improves quality. That is very clear from the work we've been doing, and I think the work that is out there.
What about the more like reasoning approach, where you differentiate and sometimes have more, inference time for a specific task, and for simpler tasks you have smaller inference time? Do you think that will be coming soon, or?
I think that's one of the interesting approaches, and it actually kind of touches the point of, there's a bit of a challenge here. Yes, models become better as they grow in complexity and size, but then also the ability to actually serve them is reduced because it becomes so expensive to serve. And I think there's a lot of work done across the industry to figure out how can we reduce the cost of inference. And mixture of experts is one approach actually that helps with that. There are other things like applying sparsity at the low level of the model computation on the forward pass. But another approach is, yes, achieving sparsity in inference through kind of differentiating based on the complexity of the task. And that, I think, is definitely an interesting approach. What I've seen currently in the industry applied by companies is also, when you think about an AI system, because most applications of generative AI today, they're not one model that is doing all of the work. It's actually a system, compound system. We have multiple LLMs. You usually have an embedding model. You have some kind of a retrieval mechanism or search mechanism, and it's all kind of orchestrated together. And one of the practical approaches is actually, yes, use different models for different tasks. So maybe you have one model that's actually doing classification of the task or some kind of annotation on the input. And then based on that, it fits to different models. And these systems tend to be much more efficient for serving.
Agency.
Being able to actually consolidate that into a model that is capable of making these routing decisions within the forward pass is, I think, one interesting approach that some organizations are pursuing.
Do you think agency as well, being able to have models taking actions by themselves and collaborating together to solve a task will be something we're going to see in the future?
100%. Yeah. Agents is the next killer applications of generative AI in my mind. And again, we can talk for an hour just about agents, but it's already coming when models are fine-tuned to make API calls, and that's an important enabler for agents, and it is already here, right? So I think we'll see more agents.
Let's book another hour and talk about agents. That would be fun.
And I know you have to leave now in a couple of minutes. And what to say, Goran?
Yeah. Hagay, how much time do we have left?
A few minutes.
Oh, good. Okay, so we are sharp on 1 hour. Okay, cool.
Okay, so final question then, Hagay, and we'd love to speak more about different things, but let's go a bit philosophical and think about the potential AGI future and assume that there will be a point where we'll have AI models that is surpassing most humans. You can think it's becoming either more of a utopian future where we'll have AI working together with humans and becoming like a paradise where we're free to pursue our passions and it's solving all of the crises and challenges we have with healthcare and whatnot. or it can these more kind of dystopia nightmare, the Terminator movies, machines trying to kill humans. Where do you lie in this kind of scale? What do you think about the future?
So my answer is a bit nuanced. First of all, I think technology, like if you look at the history of our species, right? Technology is a force that is just unstoppable. It's almost like we are programmed to build better and better tools, and I think that would continue, and it will take us to a place where AI is super capable, and I think definitely more capable than the average human on any given task. I would argue actually we are very close to that already.
Yeah, like a number of years, or?
I think so. Yeah.
Yeah.
I think we'll. And now again, the definition of AGI is like all over the place. There's actually a really interesting paper from Google that tries to define levels of AGI. Yeah, but I think if you think about AGI as an AI that is capable at most knowledge tasks more than the average human, then I think we are very close to achieve that. And anyone who interacted with a model like GPT-4, I think can get a sense of that. Yeah. So I think the future is positive. I think it's already making people more productive. I think it's enabling people to get more done with less time and less effort. And it also enables better decision making. Yeah. And again, if we go back to our discussion of autonomous vehicle and FSD and Waymo, again, I think Waymo is safer than the average human easily, on a task of driving a vehicle in the street. So I'm positive, cautiously optimistic about our future with AI, but I also recognize we need to put in regulation in place. Governments need to regulate the deployment of AI, just like they do with aviation, and they do it with medical devices. And I think that is key to make sure that we avoid a lot of the challenges around, mass influence campaigns, really having a negative impact on democracies all over the world, terrorist organization using this technology to generate harm, and a lot of other bad things that can happen. But I think with the right regulation and the right systems in place, we can avoid most of it.
Yeah, very well said. That's a perfect ending word, I think. And so great to have you here, and that you can spend some time with us in the early mornings of California. So thank you very much, Hagay Lupesko, for joining us in the AI After Work podcast.
Thank you, guys. I really enjoyed it.
Thank you. Bye-bye. Awesome. 1 hour goes so fast. I mean,
so many questions I want to ask.
Yeah, and so many questions we skipped now.
Yes.
But I thought, we had to include at least the endings and the future of LLMs, etc. So,
yeah, I think it was interesting with the open source thing. He mentioned the positive sides, and I was reading yesterday something from Andreessen Horowitz about how companies, how enterprise, which is what they're looking for as customers, how they are moving towards open source. If you compare it to 2023, it's increasing the number of companies that are using open source models, because they don't have to be afraid of the data leaving the building, so to speak, and they can fine tune easier. So I think that's got to be a given thing. If you open source it, and then the companies can take it and use it as they want, which has to be a positive, even if they don't serve it, but you still have the infrastructure in Databricks, so that's got to be a positive thing.
Yeah, I'm still a bit perplexed about the future, in a couple of years, how we'll see either some really, really big foundational models taking over, or open source will still. I mean, we were thinking about having the news section, and we previously spoken about the $7 trillion investment that Sam Altman spoke about compute and the infrastructure for AI. And if you have that kind of compute needs in the future, it will be very few people that can train any of these models from scratch. Yeah. So it will really accelerate, in my view, the AI divide and the very few tech giants that can actually build these kind of models.
I think so. Yeah, I agree with you there. I think this is what's happening right now, here and now. It's good with the open source models, and once you see GPT-5, I think, will you want to go back to something that's not a super model then? I don't know.
You would wish you would instead have a large number of small open source models that everyone can democratize in some way and everyone can have access to. But I don't think that will be the future, unfortunately.
I'm so excited to see. I mean, we started talking about that with Hagay, this inference time compute.
Yeah.
That will be so amazing when you can tell the computer, when you can tell the LLM to just pause and think about this for a day or two.
Yeah.
Like, what can you achieve at that point? That's gotta be out there.
When I'm using ChatGPT and GPT-4 these days, I can notice at least that some questions you ask it, you get the answer so much quicker than for other questions. I think they already have some kind of inference planning or some kind of search in place for ChatGPT.
Could be, or maybe you're just trying to make it feel like I asked a really good question now. That's what I think of myself.
No, but I think and I kind of sure that OpenAI are continuously updating the existing models. That they.
I heard definitely.
I saw Sam sometimes saying, you want to have more of a continuous kind of improvement, not this kind of large steps going from one version to another. And I'm sure that's very, very efficient from a cost perspective to, when you have a simple question, just a factual kind of Jeopardy question, there is no point in spending the huge amount of compute on it. You can just either go for a smaller model that can serve that, or you don't have the additional kind of inference compute time. Do
you think the model will know that this is a simple question, or do you think I will tell the model this is a simple question? How do you think it will work?
Yeah, good question. I guess you can take one inference step in a small model first, and it will say, I'm not sure. Then you have to move on to a bigger model and perhaps do some inference steps, number of times.
You can have some verification step like this. Let's verify step-by-step paper. Where
it starts with a simple one to just, if it can, with high confidence, say, I know the answer, then you stop there. Otherwise, you move on to other models, or you move on to more iterative kind of inference steps.
Yeah, I feel always like I would want ChatGPT to stay a bit with the question. It's often you get this reflexive kind of, yes, this is how it works, but it's maybe you think about it for a bit, and then that would be nice.
What do you think, Jesper, by the way, about the JEPA approach, saying, I think it's kind of obvious that should be the direction that, today when you do the next token prediction and do the inference step in the token space, so to speak, you actually have to produce a token to know what next token should be. It's very inefficient. And if you instead could do the inference, in the latent space in the middle of the model, and then there, you just move around in the latent space, and you don't have to produce the tokens, and you move away from these kind of autoregressive models that Jan LeCun is saying all the time. This is not the future, and he's very negging on this kind of approach. And I must say I agree. I think it's kind of absurd how we are doing this kind of very efficient.
I'm a bit on the fence there. It's it does seem like a nice thing, and I have some problem with my imagination seeing this sort of walk in latent space, how that would work. I'm sure it sounds like a good idea. Then again, if it's that good of an approach, why doesn't Meta do something like that? I haven't seen anything around JEPA that's
I think
available.
the JEPA is doing that. The video generation part of it did that. Similar to Sora, actually, from OpenAI, they also did the inference in latent space, and actually Stable Diffusion, when it first came out, also did inference in the latent space and didn't go to pixel space, so to speak. So I think we actually seen a number of approaches already going in that direction.
Yeah, it could be. Yeah, I'm just looking for like Llama. Is Llama 3 going to be in?
Why didn't it do that there? That's a good question. I think that the next Llama potentially will be some kind of JEPA inspired kind of model.
Yeah. Should we move on to the news section?
Let's do that. Do we have the
Something is happening.
Perfect. AI News, brought to you by AIAW Podcast.
So normally we have the news section in the middle of the discussion, but given that we only had 1 hour with Hagay, we chose to do it afterwards. And should I start, by the way? Or?
You can start. I have only a couple of smaller things, and I think your news seems like a better. We talked about it briefly before, and I think let's stay with that one for a bit longer.
Yeah. No, but it's continuing the discussion that we just had about how the big tech giants, the superscalers of the world, the tech, they are basically running away now faster and faster to build compute. And as Sam Altman and others are saying, the compute will be the new currency of the future. Yeah. It's not necessarily the dollars. The one that have the most compute will win in some aspect. And Microsoft just announced, that they, together with the OpenAI, of course, since they are basically very intertwined these days, are planning $100 billion data center to build a new supercomputer in coming years. I think in 2028 or something. And this will, I believe, be like millions of H100 kind of compute. And Meta just released like a month ago that they are planning to build at the end of this year. They will have 350,000 H100 data center, which is insanely much bigger than a lot of other. Google, of course, have so many TPUs, etc. So they already have a lot of compute. But now that also Meta has it, now Microsoft will have it. These three companies are running away and accelerating away, I would argue. So everyone else is getting further and further behind. And this kind of 100 billion data center approach, which will be like this kind of 5 phases apparently, and they're currently in phase 3, and this kind of Stargate, as it's called, they call it Stargate data center.
They're good with names.
I love the Stargate from the movie, I guess. Will be the phase 5, and will that be the AGI backbone? I guess so.
I heard some comment around Stargate and AGI recently. I'm not sure if it was somebody at OpenAI or where this person was from, but it's obvious that everybody's rushing for compute. Everybody wants to get as many H100s or A100s as they can, but they're also recruiting a lot of people. So that is an interesting thing. Like, if we would see AGI in a couple of years, do we really need to hire more people? That's a scary question to ask, but that was thrown into this discussion as maybe we're not so close to AGI as we think. I mean, we talked to Hagay; he seems to be on par with what we're saying. Like, in a couple of years, we will see AGI. That's what I think, and I think what you think as well. Yeah. But a counter argument could be like, why do you need more people at this stage if the only thing you need is more GPUs and more inference?
I think we will simply adapt to it. It's similar to what we did with the printing press or spinning jenny, or with Ford and their.
That was much slower.
But still, what happened when you got this kind of increase in productivity, as you did with all these kind of technological revolutions, was simply that you want more of it.
Yes.
And I think that will happen now again. So now when the cost will completely, reduce for so many tasks.
Elasticity thing. Like, if you have if the price goes down, then you will get more demand for it. I think
it's not that we're lacking things to do. I mean, from a medical point of view, we have so much things to do. From an education point of view, from a security point of view, there is so many things that we are currently bottlenecked with.
And just from my experience being at companies, it's like you can never employ enough back-end engineers or front-end engineers, people that can do and iterate on coding. And if we now would have infinite power to do those things, I think we'll just see crazy things happening. What will be the next things that we develop?
It will be as Elon Musk calls it, the world of abundance, where products and services become more or less free.
Yes.
But I'm a bit afraid, because the one that will get first to the AGI approach, their kind of power, their kind of economical wealth that they will achieve from this will be insane.
Yeah. And that's obviously why everybody's rushing right now. Everybody wants to be first. It's a little bit of a winner takes it all kind of thing.
Yes, potentially. Or at least the one that are in the game, so to speak. I mean, you need obviously huge amount of compute, and we can see these kind of top 3 players in the world. Oh, and of course China is doing the same, so we shouldn't of course count them out. I think Amazon also, they are investing in Anthropic with the Claude 3 thing, and I guess they are letting Anthropic then use Amazon GPUs for this, so they're trying to catch up. But from US point of view, it's like 3 major players, I would say right now.
It was interesting to see Claude 3 beating GPT-4 finally.
Yes, at least someone is getting close and even better than GPT-4. No, but this is scary. Scary. I mean, I think it's a bit scary that we are seeing this concentration of power, as I see it. With a huge amount of spending now being done on compute, and it's done very, intentionally, because they know they will get it back tenfold, and the one that will have sufficient compute to reach AGI or to reach a high level of AI capability, they will make so much money from it. That it's worth every penny of it. And
would there be a better way of doing it? I mean, should we regulate, and how could we regulate?
How could you regulate? Could you regulate companies from investing in the technology? I don't know.
What will another question on that theme? Like, what will happen to OpenAI? This non-profit thing. They have this clause that when they reach AGI, then Microsoft cannot use the technology anymore that they made. What do you think will happen to that? Do you think that they will, maybe they already have AGI and they're not releasing it just because they want to milk it?
I think Microsoft have all the competence, all the code, all the knowledge that they need to do it themselves, even if it's kept something into OpenAI. So I don't think that will be a problem. It's hard to bottle that, and it's so quick. As soon as someone come up with a new idea, some new invention for making AI faster and better, it spreads very quickly. And I think it's not the knowledge that will be the limiting factor, it's simply the compute that will be the limiting factor going forward. So I think that's what we're seeing, exactly what we're seeing right now, like Microsoft spending 100 billion, which is, I think, like 10 times more than anyone else have spent on data centers before.
Do you know if they will catch up with Google anyway? It seems like Google is so far above. They're so far in front of everybody else at this point with GPUs.
Yeah, I haven't seen a number though.
Yeah, I just saw a graph. Like this is how much Google has, and this is how much I think it was OpenAI or somebody else, like number 2 or everybody else, something like that. And it seemed like crazy. It was like double at this point.
And I think Google is making so much money from this because they're not dependent on NVIDIA. and NVIDIA, of course, is their crazy rise on the stock market. Being more or less the number 3 company in the world in terms of market cap, because of their dominance in this field. And Google can completely sidestep that and just build their own. I mean, imagine how much money they're making from this.
Yeah. What do you think will happen to NVIDIA?
I can tell you, I sold my AMD stocks right before GTC, the big NVIDIA conference, and I'm glad I did. But NVIDIA have so much money. I heard some number on the margins, the profit margins they have on each GPU, and it's like insanely high. The capital that they are now gaining from this kind of monopoly that they have, imagine how much money they spend in research now.
I heard an interesting sort of counter argument against NVIDIA. They were talking about Cisco when the internet came. Like, of course, everybody's going to need a lot of routers, and Cisco makes the best routers, so they're going to be on top of the world, right? We all know what happened. It's like they're still a good company, but they're not like 10 times everybody else. They're like, so maybe that will go for NVIDIA as well. Once we reach AGI, maybe NVIDIA will not be the ones to benefit from that, but somebody else.
No, if they stop innovating, they will lose for sure. But they have the money to keep innovating. But my pet and favorite kind of technology, except GPUs, is neuromorphic computing, and what Sam Altman is also investing in Rain AI. haven't seen anything from NVIDIA going in that direction.
Yeah.
And if they don't move in that direction, I think
Maybe you should mention more about, is it Rain AI or what is it?
Rain
Yeah,
AI.
maybe you should say something more for listeners.
Yeah, so neuromorphic computing is moving away from this kind of standard model, the architecture of a computer that we had since for the last like 80 years, which is you have some kind of CPU or GPU and you have memory separated from it and you move the memory back and forth all the time.
Yeah.
That's not how the human brain works. In the human brain you have neurons, and they basically have this kind of spiking approach where they have, when they have sufficient signals coming in, they release something very similar to a transistor then, which is the computer approach for it. So when you have some input, the transistor will go 1 or 0. But then in a neuromorphic, you will also have a state in the transistor. So it's called like a memtristor or memristor. And so you have the memory as well. So it keeps states. Depending on what happened in the past, it will have different behavior. So it's some kind of dynamics added to the transistor or the memristor. Yeah. And then it becomes much more similar to the human brain. And then it becomes possible to not have to move data between the memory and the GPU all the time as we do today. And that is going to be insanely much more efficient. And then you can let every kind of memristor or neuron operate in parallel. You don't have to wait for some kind of clock synchronization to move data back and forth. They can simply operate independently all the time. And for me, at least, this is an obvious kind of direction. And the one that gets this right and get this working from an economical point of view, that's
interesting. There are many different kind of architectural innovations happening right now with the Grok LPU and etc. Yeah. This is a super interesting direction as well, and I guess that Sam Altman is spreading his bets across different things, and this is probably one of his hopes that Rain AI would be.
I know Intel is spending a lot of we're investing a lot in neuromorphic computing as well, but no one has really made that work from a practical point of view yet. So it's a lot of research left there to make it work, or engineering work perhaps to make it work properly. But the potential of that, I think, is insane.
Yeah, it's so Stargate. That was maybe the most exciting thing last week.
It shows what the coming years will hold.
Definitely.
It will be insane investments in compute from all the tech giants.
Otherwise, I think it's been a bit of a slow week. I haven't seen so much interesting stuff. I was saying before, I noticed something released from Silo AI about a model called Viking. Interesting. I think it's they had some kind of checkpoint. So they trained on, I think, 1,000 billion, I guess that's a trillion tokens, up until now. So they maybe released some partial model. What I thought about this when you mentioned NVIDIA, because I noticed that they're training on a supercomputer in Finland somewhere. Don't know if it's Åbo or wherever. And they're using AMD, which is interesting.
Lumo, I think it's called.
Okay.
It's a European data cluster.
Yeah, but it was interesting to read about somebody who's using AMD. It's not so common.
Yeah, and I'm happy to see that NVIDIA has some competition at least. AMD released like MX300 or something. It's a competitor to H100, similar compute with a smaller cost to it. And the dominance of NVIDIA needs to be broken, otherwise it's not going to go well.
It's a bit boring out there.
Yeah. Now I'm glad to see that we are, having also some Nordic and Swedish approaches going forward here. Yeah. To me, though, I am very afraid of the future of smaller countries and companies. Ability to simply train models from scratch. I don't think that's a sustainable approach. I think it will be these kind of big tech giants that have monopoly on building these kind of large foundational models. So either we have to move into some kind of more specialized models that you can train yourself, but then based on these kind of foundational models, so you have more of an interaction between models. I think that is potentially a good approach going forward. because a smaller country or company, I don't think could never train anything that competes with the tech giants.
Maybe we don't need to. I mean, maybe fine tuning is enough. Maybe they have this.
I don't think you can fine tune either. If you take like GPT-5, I don't think company can fine tune it and have the money to do it unless you use the API potentially and pay a lot of money to.
Yeah, definitely. Yeah. For if we're not talking about the open source models, I mean, you can fine tune GPT-4, but it's supposedly very expensive, and you can't just do it. It's a process.
But I think you could potentially have this kind of, as Jan LeCun sometimes speak about it, a number of more specific models that is, being used in together with the foundational models. So then you can train perhaps a smaller model that is specific for just doing, customer service or whatnot, customer support. And you interact with a big foundation model that can ask anything, but then you add your specific skill in a separate model that each company can train. But perhaps something like that could work.
Are you talking about like cooperating between different models, or what's the?
Yes, so you don't ask a single model once and get the answer. You first, you have more of a agentic approach,
right?
Where you ask a model that is specially trained for, let's say, do customer support, and that one goes out asking, the foundational model and gets some kind of general answer, but then it, interacts with some other models, and you have this kind of mesh of models that together come up with the answer. I think that would be a nice future potentially.
I think maybe the future of agents could be something like that, where you have different kinds of models, and maybe one way of structuring the different agents would be in sort of a workforce. Maybe you have a software agent, maybe you have a manager agent, maybe you have customer support. You mentioned there could be all different kinds of fine-tuned. Maybe you can even use. I've heard about model merging. Seems to be something emerging right now, where you just sort of almost like taking the average of weights. Somehow you just tweak the weights, and you get something very quickly. If you compare to training something from scratch, you get something that's performing quite well. Maybe that's the way forward with the future of agentic systems.
Let's see. Goran.
Hi guys, so I will join you just for the news part. As I always, I find some very boring stuff to. It's been a dry couple of weeks actually.
Yeah, I was saying the same.
Yeah. Let's see if this is continuing like this, but comparing to what was happening in the past months, this is actually a little bit boring. But in any case, so two things that I wanted to lift up today. The first one was actually that you remember OpenAI opened this marketplace where you can build your chat GPTs. So the latest news now, and there are many media channels that are reporting on this, that is basically filling up with garbage. And potentially it's dangerous for OpenAI to that extent that they can be actually sued again for illegal or infringement to intellectual property rights. But this time not because of their fault, rather than on who is training the chat GPTs. So on the marketplace, if you remember, so like they gave the opportunity for people to train their chat GPTs and then basically offer them open source or basically as a part of the platform as a marketplace there, so people can use them. But they don't have, or maybe they have not thought through the entire process, but this has given a lot of people the opportunity to train their GPTs on data that is actually then imported directly into the OpenAI. So it can be actually very smart move and very dangerous move in the same way. But in any case, so the latest report is that it's filling up with a lot of garbage that people are basically.
Any specific GPTs that are?
I don't know exactly, but I just read actually the news there, so I will start looking into it. But it makes sense actually, because if you give the power to people to actually train models on that way, you cannot foresee what they're going to add or import into the system by itself. So now, if they were smart, if their legal team was extremely smart and said like, hey, we don't actually take any responsibility for people that have trained or upload any type of documents to the system, then probably they will be off the hook. But let's see how it's gonna go. I after this I will go home and read it because I have also my ChatGPTs built. All those
I never find anything interesting in the stores. I haven't
Me
checked so much.
neither, actually. I mean, but the ChatGPTs that I'm looking for is actually a little bit more specific to the event industry and production and marketing and etc. Marketing, you have some, but you know, marketing is so specific. It's almost like the fingers on my hands. They're all my fingers, but there are none of them are the same, right? So I cannot find anything that actually I can apply into. So I started building my own ones from our data, of course, internally, etc.
Yeah, a lot of people do that.
Yes, and the second news was that actually the musicians are on the ramp again. You remember the AI art, the film artists? They were basically striking against AI because of infringement of the intellectual property rights and you know, deepfakes and whatnot. So now the musicians have actually come to play. So over 200 musicians have signed a petition for companies like OpenAI and Google and etc. to stop utilizing their voices or their
It's about the voices, not about the songs.
Yes, it's not about the songs. It's more about the voices and etc. Because I mean, the songs are already open there, right? People are doing mashups on YouTube and etc. And this one is very heavy for me because in one sense, I'm completely 100% on the intellectual property rights. On the second, on the other part, I'm a little bit more angry about this because in the same time, like I had an argument with not argument, but a discussion with my daughter as well. And she was like, oh, they need to stop with this AI because, you know, it's taking the artist's work and making, you know, making available to everybody else. But when you go to school, they teach you about how Leonardo da Vinci used different techniques to paint, how Monet did his painting. So they teach you that art, and then you incorporate that, you create something yourself, and then it's yours. But somehow now when it's applied to a machine, it's somehow estranged. So there is a hypocrisy in all of these things. So I can understand like, hey, don't use my voice. This is my actually data. This is my voice and etc.
I mean, this is the argument that everybody's making in favor of just reading the web. Like, I can go read all the source of the web, and I can write something out of that while processing it in my memory, my brain, and I can do something with it.
Right.
But then people are getting sued for that. So it's.
But why are we not getting sued? I mean, we are going to university. We are reading books. We are taking. We are utilizing the knowledge that people are utilizing,
totally
have been created for many years.
Totally with you.
And then we are basically building something out of it, which is basically the point of intelligence is multiplied knowledge combined together. This is Anders.
I think the only argument against that is sort of this scale of using.
I think it turns out to the question really: should we have different rules and regulation applied for machines than humans?
Yeah, well, that's a good question.
I don't have an obvious answer here.
No, I think it's
when
hard.
we spoke about the AI Act in EU, we always, negged on it because we thought it was a really bad idea to have a regulation based on a technology. To say that, just because you use AI to look at a video, then certain rules have to be applied. But if you use a human to watch videos in the subway station or whatnot, then it's okay. But I'm not so sure. Perhaps we will have a point in time where machines have different regulation, have different, compliance to have to comply with than humans. I don't see that as an unrealistic future.
But I don't understand why. If the whole purpose of knowledge is to basically bring innovation forward, because we are who we are today, because somebody actually invented how they can make fire of something.
Yes.
And now today basically, so in the 90s and then in the zeros, right, there was this, the music industry has been automated for many years, the same is with the graphics. So right now, for example, I have a piece of machine which is cost 1,400 euros and replace sound engineers and mix boards that were costing thousands of dollars.
Amazing.
then in the zeros and etc., people started imagining softwares like DJs and etc., where you could have taken samples and then create your own music. And then people were selling samples, which was basically, let's say the Jasper is a drummer, and he has this famous tone, right? Because how it sounds like, right? And then they ask him to play these tones and etc., right? And then they make like this drum machine that you can do it. You can use it on your computer at home to make music, right? But it's gonna sound like Jasper was basically drumming it. So at that point of time, and they were capitalizing on that. So at that point of time, nobody complained about it, right? But so the hypocrisy of this movement for me is actually just I agree with them, but I don't agree that we should basically stop developing AI on this. Rather than they should say like bluntly, pay me for my voice.
Right.
And that will be super good, because if somebody pays these artisans for every single time somebody uses them, they will not even blink of eye. They will be sitting in a Bora Bora or somewhere else, drinking some Mai Tai, and then just basically just cashing on the money.
Do you remember when there was an AI Drake song pretty early on, like a year ago or something?
Yeah, a year ago,
And then Ghostwriter or something.
Yeah, Ghostwriter. Yeah. And people were freaking out about what's going to happen to all the musicians. And then Grimes came out very quickly and said, I'm with this. Anybody can use my voice, can train on my music. We share 50-50.
Yes,
exactly. That's a good. I think that's a good idea.
And that is the right way to pose it, because I think it's critical to go as like a stop development of technology. When you eventually say like, "Hey, pay me for my voice," and then it's completely different.
Makes sense.
Yeah, but stop developing technology will not happen, of course. But I think we need to figure out the regulation that is making new work protected in some way, and this will be a challenge. And there have been a number of court cases now with the results basically coming in saying that the generated text, like New York Times sued OpenAI, etc., and they sued Stability AI, etc., for image generation, and they basically said that, well, the generation of images was not similar enough to claim copyright. And if that is going to be the approach, how are we? It's similar to the question of patents in some way. If someone is going to spend a huge amount of time creating things, but not being able to get paid for it, how are we going to?
Maybe that is a startup idea. We make a new startup when people basically can donate their voice and whoever can utilize them, but then basically they get paid for it.
Yeah,
I don't think that anybody will complain about it. Everything will be super good.
Exciting times ahead for sure. And technology is a small part of it, but the whole use of it, the regulation of it, the societal aspect of it, how the democracy will be impacted by it. It will be a lot of things coming.
All right, one more question from me. I think that the new news is over. Kirill, do you have something to add? You were reading some paper today. You didn't finish it.
It doesn't seem to have been it's published by weird pages, so let's ignore it for this time.
Great to hear. So I have been now basically traveling quite intensively the last 1.5 months across the world right now, and executing a lot of events. So it's more like a question, and then I will leave it so you can finish the podcast. And of course, no matter where you go, everything is about generative AI, and everything is about RAG. And today we heard from Hagay about foundation models and the new AI models and etc. And my question is to use I already have my thoughts regarding this, but I just wanted to hear from you. So where do you think right now enterprises are when it comes to implementing generative AI in the organization? How much is a bull and how much is actually in practice?
I can start if you want.
Or maybe not bull, but let's say experimentation phase. Maybe it's a better word.
One interesting property, so to speak, of large language models is that they are surprisingly easy to integrate into applications. That's what Microsoft started doing very early on, adding Copilot to their Office suite, to their operating system, to their web browser, and everything. And It is simple because you simply have to feed text into something and you get a reply. It's very easy integration work. And of course, Google did the same, Adobe did the same, Meta did the same. So it is getting surprisingly quick adoption, I would say, in moving generative AI into enterprises. Now, if you want to truly make use of it more than just an assistant, then it's going to be much more work. And if they need to fine-tune it, it's going to be much more difficult. But you don't need to. That's also a very interesting
RAG is
aspect.
very much enough in many cases. Yeah.
So compared to traditional AI or machine learning, where you do need to train your own model all the time to have any chance, you can simply add it to the prompt these days.
Yeah.
And it works surprisingly well. So once again, it becomes surprisingly easy to find use for it. This is a big change compared to traditional AI and machine learning. So I think the generative AI has a surprisingly big, quick impact on enterprises.
What I'm seeing, yes, I agree with what you're saying. I think a lot of companies are using it. I think a lot of companies are doing proof of concepts.
Let me just add. I think it's easy to do, but I think few companies have come to that point yet. Right. So, I mean, Klarna is one example or one exception to that rule.
I was in Singapore, and the first slide that they showed is actually Klarna.
Yeah.
Wow.
They went really quick on this route.
Yeah.
But
I don't know if it's positive or negative, because the slide was like they're firing 700 people that could be easily replaceable, but it doesn't matter.
But the big tech giants, of course, is already there, and they will simply get that out to all the customers that are using Office and Windows and whatnot, and Google Search and whatnot. As well, Google Search is now adding the SGE, the search generative experience, to the normal kind of search results now already. So I mean, it's getting integrated into everything.
I was reading also, I was reading that also there is some kind of indications that they will try to get paid for AI in amplified search.
Oh, okay, interesting.
So that is correlating with what you were saying. It might be the case, right? Cool.
But then for most other, of course, enterprises, they move slowly, but they are getting it by using the tech giants' products. In that way, they're getting it quicker. But if they truly want to change the way the enterprises work, that will take some time. But it is possible to do it much quicker than traditional AI.
Yes, I agree. So my take on this is, so I'm working at Volvo Cars now, and that's the only enterprise that I'm seeing. And I was almost shocked when I got there to see how much they're actually doing at Volvo Cars. So there's a lot of initiatives. Most of them are on the proof of concept stage, but
Experimentation.
Experimentation. But some of them are getting to a serious stage. I think the main question is: are you going to do internal things that make you more productive, or are you going to do external facing, like new types of services? The latter is much more tricky to get right, and I see much fewer instances of those kind of projects. I think the type of productivity enhancing internal tools, I think everybody is experimenting with it. I think quite few are getting it into production, but I think we're close to that, and at Volvo definitely we're sort of at that level.
What are the main challenges of not basically putting something in production or scaling?
Sorry, you mean external or do you mean
Internal.
Internal. I mean, it's tricky to get. It's easy to get to 50%, like something that works 50% of the time, basically. So last time I were here as a guest, I mentioned this text to SQL bot that we're working with, and it's very easy to get something that works surprisingly well in many cases, but making it work in like 90% of the time, that takes a lot of work. So that's I think the tricky thing. You can easily get to a proof of concept that shows the potential, and then you have to spend a lot of time to get to 90%, and then you have to do something about, okay, so what do you do in the 10% that fails, etc. Those kind of things.
Right,
and that's why I think the main approach for most enterprises and companies in general should be not to completely automate the task, but to actually augment the humans doing the task, because then the human gets the assistance but has the final touch, and you don't have to being able to handle the edge cases.
That's a very deep question. I've been spending a lot of time thinking about that. I think we will get to the agent type of situation quickly, but right now, definitely not. What I'm seeing right now, I'm trying to picture a world, an enterprise world, or a mature company world where the agents augment the humans, and you will have smaller teams that can take on much more things by having sort of a more broad capability per person, and smaller teams, and more like...
Or phrase it as a team can handle 10 times more tasks, 10 times
Exactly.
more productively.
And you can scale the capacity up and down according to the task. So if you have a huge project, now you just switch on the more agentic workforce, and it has a cost to it, but it's easy to turn up and down, because it's just going to be this the builds to the API or the fine-tuned models or whatever, maybe some inference time compute, but it's what we're seeing in terms of dev in the software agent. It seems like it's definitely possible to get to a stage. Just turn on GPT-5, then we will get to a case where we can handle a lot of cases with the agentic workforce.
Yeah, still to see, but I think that's going to be a focus for this year. Much more agentic kind of work. Yes. Cool. Okay, with that, we
Let's round it
spend much more time on the new sections, and but a lot of very fun discussions. And it's always amazing to speak with you, Jesper.
Nice to be here.
And awesome, of course, to have a guy on to have directly inside information about the training process of DBRX.
Yeah.
So with that, thank you, all of you, and have a great evening.
Thank you.
Thank you. Bye-bye.